Welcome to this recording of our webinar on learning version control with Git. Let's start with what version control is actually. So every project evolves in little steps. So you might start with modifying an index.html page. A couple of days later, you modify a about page, add a photo, and yet a couple of days later, you again make modifications to that about page. So version control is about those modifications to your project, and version control saves those modifications in a safe place in the version control repository. And it not only saves the bare modifications, but also some metadata. So the commit subject, a message that describes what has happened, the author name and the date, and much more. So later you'll be able to look at the project and see how it evolves in those little steps. So the next question is, why should you use version control? If we look at a world without version control, it might look a little bit like this. So this could be different versions of a project, and a lot of people simply copy the project folder and append the date at the name and even some variants. The problem with this is, what exactly was changed in each version? Does anybody know? Did anyone take the time to comment, to document the changes? Rarely so. Uh, and why did we store the whole project instead of just the modifications? This is very inefficient. And another big question is, how do you keep those variants in sync? Because the project will move on. So while you're waiting for approval from your client, if the red version of the website is good, the project might move on. So when he later says yes or no, you might have to merge or combine different states of the project. And this is very hard to do without a version control system. So the benefits of using version control are, you can save versions properly, not just copying a project folder. You will understand what happened. You can restore previous versions. You can always come back to a previous versions if anything goes wrong. And another big benefit is you can collaborate with your teammates without overriding. So different people on the project can even work in the same file without overriding their changes. And that's really just a side effect. It's not the main purpose of using a version control system. You get a backup, actually. So one step further, this means reliability for your project. You can always recover. You gain confidence because you know you can't mess up, because you have a safety net below you. And of course, it also increases quality in your project. Another good thing about version control and version control with Git is it's completely independent of the operating system. So you can use it on Linux, on Mac, on Windows, and it's also independent of the tools. So there's no special editor or image processing app or IDE you have to use. You can use your favorite apps to work on your project and don't have to worry about that. And it's also independent of the language or the framework. So version control is nothing that only is available for Java programmers or for PHP projects. This can range from simple web projects to desktop projects to not even coding projects to design projects and writing projects. So let's talk very, very briefly about installation and setup. Very briefly, because it's quite a boring topic and not a very insightful one. You can look this up in our free online book, which you already know. But to be complete, let's talk a second about this. On Mac and Windows, you have very easy one-click installers to get Git on your machine, and on Linux, the Linux users already know the yum and apt-get commands to install stuff on their machines. After installing, you will find a Git Bash application on Windows, and on the Mac, you already have that terminal app, which you can find in Applications, Utilities subfolder, um, which is the well, one of the most used applications for using Git on a Mac. And before you start, you should make some configurations. The first two lines here are to identify yourself. So this data is used later when making a commit, when saving a version. Um, it will be logged under your name and your email address that you can configure here. And the third line is to enable colors on the command line, which is helpful reading output. Okay, so let's talk a bit about the basic workflow of version control. So you have an overview of the individual steps that are necessary or that are involved in using version control. So the first one is getting a repository onto your machine. You have two options to do that. One is create a new repository in a local project, a project that is not yet under version control, one that you have started on your computer and now want to start version controlling. Um, when you create the new repository, you get a local repository side by side to your working copy, to the place where your actual working files are placed on your disk. The other possibility to get a repository onto your machine is to clone from an existing project on a remote server. So if a project has already started, chances are someone has already created a repository and placed it on a remote server. So you can clone, as we say in the Git world, you can download that remote repository and not only get that local repository on your machine, but also the working copy, the files that belong to the project on your machine. So as soon as you have a repository, you can start or continue working on your project files. So as I already said, editing, adding, deleting files, renaming them, copying them, is possible in any application. So you can do this in your favorite file browser, IDE editor, or image manipulation program. This is completely independent of version control. After some time of working on your files, you will want to get an overview of which files exactly you changed, how exactly you changed them. And so let's assume you have four modified, that's the M in the sketch, modified files and two new ones, two added ones. Um, the important thing after having modified some files is you want to decide what to commit, what should make up the next version. Um, and this is a bit special in Git and special in a good way, I think. You need to tell Git which of your current changes you exactly want to have in the next commit. So just because you have modifications or just because a file is modified on your disk doesn't mean it's automatically part of the next commit. You explicitly have to tell Git by staging those changes. So adding them to the staging area, as we say in Git. And the next step is actually rather boring, committing to the local repository. So wrapping up the changes you just marked for that next commit and saving those changes as a proper version. And as I said, you need to add a message, and the author and date is automatically added to that set of changes. After having worked some time on a project, you might want to inspect the history, the log history of the project. And this is just an example for such a history. In Subversion, if some Subversion users are here, this is also called the log, and you might know this from Subversion too. So one optional last step is to share your work via a remote repository. So if time comes and you want to publish your work and share it with work of your colleagues, you can do so by using a remote repository. And of course, also your colleagues will do the same. So this is the means of exchanging work. Okay, so let's start creating a new local repository. The command that is used for this is git init, and we'll explore this simple command on the command line together. So let's see what we have here as a example project. So this could be an example HTML or a web project. You see a couple of HTML files, a CSS image and JavaScript folder. And let's say we want to start version controlling this project. So what you do is type git init and git response by saying it initialized an empty git repository. So empty is really an important word here. So it didn't just commit the first version, it only initialized an empty repository. And let's take another look at the project structure. And you see there is one new folder here. This is a hidden .git folder, and this is the local repository, so the place where the magic happens, you could say. You don't have to look inside of that because this is Git internals, but it's good to know this is your local repository. Okay, so let's go one step further and look at cloning an existing repository from a remote server. You remember that I already explained cloning is a Git word for downloading a project from a remote server and getting your own local copy of the project. So the command that is used for this action is the git clone command, appended by a URL. And the URL can take many forms. The first two in this list are actually both SSH protocols, just look a little bit different. And HTTP is an option, HTTPS, of course, and Git's own protocol, the Git protocol. The Git protocol is pretty fast, pretty efficient, but it lacks authentication. So in most projects, you will use SSH or HTTPS, which support authentication. Okay, so let's look at cloning a repository. Let's say we want to clone a repository from GitHub. GitHub is a very popular code hosting service, mostly known for its open source projects. And let's say we want to clone the Git crash course repository. So it responds by cloning into a local folder, and let's see what we got here. Okay, there is this new Git crash course folder, and let's take a look at the contents. And again, you will see we just received this local repository along with the project files. But it's important to know this is a full-blown repository. This is very special to decentralized version control systems like Git or Mercurial are. The thing is, having such a local repository gives you a full-blown repository. This means you have the complete history of the project inside of this local repository. So if backups should fail on your central server and work is lost, it actually is not, because every developer that has a clone of that project on his disk also has the full project's history. So nothing is lost. That's good to know, good to keep in mind. For the Subversion users, the git clone command is roughly the equivalent of the svn checkout command. However, be careful, the checkout verb is used in Git 2. We'll come to that a little bit later. Okay. So now let's look at the status that a file can take in version control with Git especially. So when working with files, we're talking about local actions. So this all happens on your local machine, and we divide this in 3 levels. So you have the working copy, the project's files. We already saw that, the place where those HTML and CSS files lie. Then we have the staging area. This is a in-between zone, you could say, where Git marks changes for the next commit. And you have that mysterious .git folder, that local repository on your machine. And files in version control can have 2 general status. One is it's being untracked. An untracked file is one that is not known to the version control system, to Git yet. So you could say it's a new file. And the opposite, of course, are all the files that are already tracked, that are already checked into version control. And these tracked files can, of course, be unmodified. Unmodified means they weren't changed since the last commit, and they can be modified. This is the most interesting status for us. So local modifications since the file was last committed. And now I can add those changes in a modified file to the staging area. I can mark the file to be included in the next commit, and then later commit it to the local repository where it's saved as a version. Let's talk a little bit about the staging area again. I will stress this point on and on. Staged means it's included in the next commit. So again, just having local modifications on your disk doesn't qualify those modifications automatically to be in the next commit. You have to stage them. And there's a golden rule of version control, and it says commit only related changes. This is an important part in understanding the use of the staging area. I'll make an example. This is an example for a bad commit message because, well, I fixed front-end bug number, blah, 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 implemented login feature, restructured navigation, and did everything else in just one commit. So this is actually like a folder on your disk where you cram in everything. So that the point is when making commits is to be granular, to just wrap up changes that really belong together to the same topic. So one feature should be at least, and in most cases many more than one commit. Even a bug fix should be one commit. You shouldn't mix topics. This is very important to make version control useful, actually. So let's look at all of this in practice on the command line in real life. And we'll look at the git status command, the git add command, and the git commit command. So let's start with the first one. In the meantime, while we were talking, I have made some modifications on the project files, and by querying git or by executing git status in the repository folder, I get an information about the current status of the project. So Git clusters already into different areas. So changes not staged for commit um, are and deletion. The error HTML was deleted, and we modified the about CSS and an index HTML file. And we also see we have an untracked file. We have a new file, the new page HTML. So just to make sure you have listened in the last few minutes, if I now do a git commit command, nothing should happen. And Git confirms this. No changes added to commit. Why is that? Because I haven't added changes to the commit explicitly by staging them. So let's do this now. We use the git add command and say that the new page and the changes in index.html should be included in the next commit. And the deletion of the error HTML file. We have to use the rm command to confirm the deletion of the error HTML file. Okay, so let's use git status again. And you'll see the headlines have changed. Now it says changes to be committed. And you'll see the 3 files that we just added to the staging area. And we still have the headline changes not staged for commit. And this is the about CSS that we chose not to stage. And we'll just leave it for later modifications, or maybe we'll discard it because it wasn't the right thing. Okay, so now is the time to actually perform the git commit command and give it a meaningful message and a very simple feedback. And again, you will use git status all of the time. Git status now says changes not staged for commit, still the about CSS file that we left before. So let's take a small excursion to a GUI client, so you can see how to do this in a GUI too. Staging is just a matter of clicking here in the status column, and in a graphical user interface you often have the chance to be more granular. You can also say, I just want to have this modification, this part of the file staged for the next commit. And you see that only this modification will be part of the next commit, but not the other stuff that we did inside of this file. And if we want to commit, we can do this. We can do this too. And again, it leaves us with the stuff we chose not to commit. Okay. So let's talk really briefly about the commit history. One command is the interesting one for looking at the commit history, and that is git log with different flags and options. Okay. So as said, the git log command shows you the commit history of the project in a chronological order, and I'll mark a commit object for you. So this is a commit. And let's start at the bottom. You see the commit message, the subject of the commit. Then you see the date when it happened, and the author who made the modification. And this is a bit more complicated. You see a commit hash up here. The hash is a 40-character string that uniquely identifies a commit. In centralized version control systems like Subversion, this is a little bit simpler because it's a ascending revision number. So from 1 upwards to how many revisions you ever should have. In a decentralized or a distributed version control system like Git is, um, ascending version numbers don't work anymore because Git can be used offline completely. So if two developers on the same project work offline and both make commits, who is number 5, who is number 6, you can't tell anymore. So the identifiers here are the commit hashes. You don't have to use those 40 character monsters all the time. In most projects, 7 or 8 characters from the beginning are already enough to identify a commit uniquely. There are a couple of flags of options that you can add to the git log command. Let's take P. P will show us the patch or the diff, so the detailed modifications actually, and we reduce the output to just one commit, to just the most recent commit. And you see a couple of more information in addition to the metadata that we just saw. Black on black is not very good, so I highlight this text. And you see, this is the diff for the error HTML file, and there are a lot of minuses on the left. So the old lines all have been deleted. This was the deletion of the error HTML file. Let's look at the other modifications. Yeah, we modified the index HTML file, and you see the old line here, the one prepended with a minus, was replaced with this line here. So we changed the href argument here. Okay. Again, let's have a look at how this works in a graphical user interface. You have the history of the project available here, and you can easily step through the commits and have a look at the detailed changes over here. Okay. So let's talk about a very very important topic, because when people ask me why they should or why they could use Git as their version control system, my number one answer is definitely branching and merging, and number two also branching and merging. Branches are a means to keep separate things separate. You can think of them a little bit like folders on your disk. Um, if you have an invoices folder, you should make sure that only invoices are in that folder. So you keep separate things separate. This is the same paradigm that branches work by. The reason why we need this so desperately is because work in the real world happens in multiple contexts, in multiple topics all the time. It's not realistic that a developer or a designer can just close his door and ask people not to disturb him during the next 8 weeks until he's finished with the feature. He will always have to work on multiple features, on bug tickets, on anything. So he has to switch contexts. In a world without branches, this is what happens. Everything is thrown into the same context, and this is a recipe for chaos. I deliberately left those little red lines in there because it looks chaotic, and it is. So, because everything happens in that same context. Keeping separate topics, separate features in their separate contexts helps you understand what happens, because in a big project, many topics, many contexts are being worked on, and a developer would be overwhelmed if he had to look at all the changes in all those contexts. So separating them in their individual context helps him only look at those that really interest him. It makes it also easier to undo changes, because if you see that something doesn't work, maybe a whole feature doesn't work, or the client doesn't want it anymore, you can throw it away in seconds, instead of picking out the individual code parts after they've been mixed with the rest of the code. And of course, it keeps stable code separate from experimental, from developmental code. So stable code is, of course, kept in its own separate context, and everything you experiment with, new ideas, new features, um, get their own branches, their own contexts. And this greatly facilitates experiments, because you can't mess up, because if you do, only your own context will be messed up, not the complete project, and nobody else will suffer from mistakes that you might have done. So this is the same diagram that we just saw, but with branches. So each topic gets its own context and is completely separated from any other context in the project. A context can be really a feature or a bug fix, an experiment, anything. When talking about branching, we need two more terms so we can talk. One is the head. At any point in time in a project, one and exactly one branch is the currently active branch, the checked out or the head branch. So the head is just a pointer that points to to a branch actually, and to the one that is currently active. And this is very interesting to keep in mind. In Git, you are always working on a branch. So if you're thinking right now, well, branching, I'll look at that later. You are always working on a branch in Git. So you better get familiar with this core concept as soon as possible. Talking about the head, you definitely want to switch the head, switch the currently active branch during your project many times. And this is done with the git checkout command. So checkout moves the head pointer to a different branch and makes that branch active and the current branch. So enough talk. Let's explore the git branch, the git checkout, and the git merge commands on the command line in practice. So let's say we want to start working on a new feature. So what do? We create a branch and we call that branch feature B. Very ingenious, I know. Let's look at what happened. Oh, by the way, this was the time that it took Git to create a new branch. So if you should ever think about creating a branch or not creating a branch, just do it, because it's very, very quick. As you saw, it's easy, it's very cheap. There's nothing to lose by creating a branch. Let's see what happened. Okay, with the branch v command, we get a overview of the current local branches, and we see a feature b branch is there. We just created that one. And you see, well, there is another item. There's a master branch, but we didn't create this. And this is the point that I just mentioned. You are always working on a branch in Git. It's not a choice, it is a core design in Git. So the master branch is just a convention. It's not a magical branch. It's just a convention, and it gets created automatically when the project is created. And you see that little asterisk here on the left, and this marks the current active branch, the current head branch. So before we actually start working on our feature, we have to make that new branch active. So let's check out the feature B branch. And as you see, switching branches is just as easy as creating branches. It's quick and easy. So let's not do too much for this feature development. Just create a new empty file, feature B file txt, and add this file to the staging area, commit it. Not a good commit message here. Please don't follow my example. And now let's see what this actually did. So we want to add, yes, give him the file. So I'll just add the work we just did here. Whoop. And show you what happened. So if we look at the file structure of this project, you see that we now have this empty feature B file on our disk in our working copy. And if we check that in the feature B branch, you see we have that commit that we just did, the new commit on branch feature B commit. So nothing mysterious until now. If we look at the master branch, we see that this commit is not present. So this is to illustrate that really those contexts are separated. And if I checking out branches in Tauriz, just double clicking and take another look at the working copy, at the actual files, I see that the feature B file is not there either. So these contexts are really separated from each other. So no matter if I mess up in my feature branch and make something very stupid, it doesn't affect the other contexts. And that is very, very good to know. So let's return to the command line. Let's say we want to integrate the changes we've made in our feature branch and integrate it into our master branch, let's say. So there are two steps involved here. First, we switch to the master branch, the branch that shall be the target of the integration. We just did this in the GUI, and then just type git merge and the name of the branch that we want to merge. And this is it. So you've now seen creating, switching, and merging branches, and everything is blazing fast and pretty easy. So if we now take another look at the file structure, and you see we're still on the master branch, this is the head branch, and you see the file feature b file txt is now here because we just integrated. And in the history, you also see that the new commit on branch feature b commit is now in this context too. So this was the act of integration. This was a merge. Okay, let's talk about another very practical, very handy topic, saving local changes temporarily. So let's say you're working full steam on a feature, and I guess it's always like that, and an urgent bug report comes in. So the question is, what do you do with the unfinished work? And before you answer, I want to present another golden rule of version control, and it is never commit half-done work. So we're in the middle of doing something in our feature work, and we're not finished yet. So what do we do with this half-done work? We could, let's see, we could print it out, but that makes it a bit hard to reintegrate later. We could copy the project folder and restore it later. We could put the stuff on a clipboard. Nothing is really practical, and committing is not a viable option in this scenario either. Luckily, Git has a solution for these situations, and it's the stash. The stash is a kind of a kind of clipboard on steroids, I'd say, because you can save your local modifications on that clipboard and even on multiple clipboards and get a clean working copy with that. One question is, when should I use the stash? You should use it whenever you need a clean working copy. So whenever you need those local changes gone, the stash is the right thing to use. So when switching branches, for example, when pulling changes, when merging changes, these are all situations that are best done with a clean working copy. So let's look at this on the command line too. Again, let's see what the current status says. And it says, okay, change is not staged for commit. So we see we have at this moment two local modifications and the bug report drops in. So we want to have a clean working copy to concentrate on our bug fixing. Maybe we have to switch branches or um, pull in remote data, and that doesn't matter. So git stash is the only thing we have to do, and it says saved working directory and index state work in progress. That's the whip. And if we type git status another time, we see nothing to commit, working directory clean. So git just really saved those local modifications on that clipboard, and we can use the git stash list command to get an overview of the currently available clipboards. And we see we have those, well, the names are a little bit impractical: stash at, and the curly braces, 0 curly braces. That's really the name of the stash item, and we see on which commit it was based. So you can have multiple clipboards, multiple stashes, and the latest one will always be number 0. So let's assume the bug got fixed and we want to return to where we left before the bug occurred, before it interrupted us. And this is a case for git stash pop. So the pop command really creates the modifications that we just saved, and also deletes the stash item, because we, in most cases, you don't need the clipboard item itself anymore after restoring the changes. A very, very practical tool, git stash. So this is the last conceptual topic for today. Let's talk briefly about sharing work via remote repositories. So until now, with the exception of the clone command, we've exclusively worked on our local machine. So this is very good actually, because it makes commands very, very fast. We don't have to wait for network connections, don't have latency. We can work offline. All of this, all of the things we did were happening on the local machine. So we modified, created, deleted, moved files, we staged them, we added them to the next commit, and we committed them to the local repository. There are just a handful of commands that are available for remote interactions. The clone command, of course, we used that in the beginning when we downloaded a project from a remote server. There is the push command. Push publishes or uploads your local commits to the remote repository. And of course, your teammates will do the same and publish their changes too. And for the other way, for downloading new changes, you have two commands. You have the git fetch and the git pull command. The difference is git fetch only downloads new commits to your local repository, but it doesn't manipulate your working copy, your current head branch. And this is the difference to the pull command. It also does a fetch. It also downloads the changes to the local repository so they can be inspected, but it also merges, it also directly integrates the changes right into the working copy in your current head branch, so that the pull command is actually fetch and merge combined. We'll look briefly at the git remote command, and the other commands are git fetch, git pull, and git push. Okay. So As said, git remote is an interesting command, and with the v command, with the v argument, we'll look at which remotes are connected with this local repository at the moment. And although we see two lines here, it's actually just one remote item that is connected. You see a short name here, so you don't have to enter the long and clumsy URL all the time. So this is a short name and two lines instead of one. The reason for this is you can, in theory, you can define a different URL for read access and another one for write access. This might be interesting for some situations. One thing I want to show is, or want to make this clearer, remote data is really, or remote repository better, is really the same object as a local repository, but it's completely separated. It's really two repositories that are talking to each other, and also the branches are completely separated from each other. So the master branch here on the remote repository could be named differently. It's not just a coincidence that it's also named master and that we also have a local branch that is called master, but those items are really separate from each other. Thanks for watching. I hope this introduction gets you started. Also make sure to check out our desktop client Tower for Git. We have a free 30-day trial. Download it on git-tower.com.